Good morning or good afternoon, depending on where you are joining us from. My name is Magdy Hanna, and I am pleased to spend the next hour or so with you to talk about defect prevention. Thank you for taking time from your busy schedule to join me in this webinar. This webinar is being hosted and sponsored by the International Institute for Software Testing, the leader in education-based certifications and training. We hope that many of you probably have taken courses and training from IIST. Actually, this month we are celebrating our 22nd anniversary. We've been in business for 22 years. We have provided training and professional certifications to professionals around the globe. Please go ahead and visit the IIST website to see what kind of courses we have there. Well, let's get started here. I want to start with my agenda. My goal today is really to talk to you about how we as testing professionals can not only find defects and write bug reports, because that's a typical thing we all do. How do we really do our job in a way to prevent defects? So I'm going to start talking briefly about why we need to prevent defects. Then which I don't expect it to take much time, because I hope I don't need to convince you much about why we need to prevent defects. But then it's important for me that you understand really what defect prevention means and how different it is from defect detection. As an intro to our topic, I want to make sure also that we all understand the difference between quality assurance and testing. In other words, quality assurance and quality control. And before we talk about different methods to prevent defects, we really want to understand the major sources of defects that are most expensive. Of course, there are defects are always there. There are so many sources of defects in software. In this presentation and on all my talks about defect prevention, I focus on those defects that are most expensive to fix. And we'll see where they come from, and then right away we're going to move on to three methods at least that I know of. I've been teaching people, I've been coaching organizations to use to prevent those defects. And those are closing the gap between development and testing, scenario-based development and testing, and impact analysis. Again, as I said, there are other types of defects. There are other sources of defects, and for those sources of defects, there are different ways to prevent them. But let's only focus now on the ones that are most effective to, most expensive to fix. All right, I don't want to waste much time here. So I am sure if I asked you, why should we prevent defects? The typical answer we get from people is defects are bad. Defects make our customer upset. Defects make us look bad. Defects just not good to have in any product. Well, these are the typical answers I hear from people. But let me share with you, and of course, in general, as everyone says, defects are expensive to fix. It costs time and money to fix defects. And that's why probably most of you think that it's important to find those defects before our customers find them. But let me share with you what I've been using. When I go speak with management to convince them about improving their process. why defects are terrible. This diagram is very simple. We're all familiar with. The development team works hard. They build their software, they build the design, they build the code, and they send us what do you call it, a build, or if your project is an agile project, then they send you an iteration or a sprint. So we get the code into our test environment, and we test. And what do we find? We find defects, and we write bug reports, and those bug reports go back to the development team, and they work hard on fixing those as well, and they send us back what I would call bug fixes. All right, but we all know what else we get with those bug fixes, right? Just to think for a minute and make a guess. So if you guessed it right, what we get here is really more defects, more bugs. I hope you are not going to ask why. Well, because when we try to fix a problem, we might cause other problems. And if we don't believe this is happening in other areas, it happens so much in software. Well, I am sure you've had this experience before. You took your car to the shop one day to fix a problem, and you walked out of there, and over a week or two, you discovered that there is another problem that was not really related to the first problem. And you go back to the shop, whether the shop is willing to admit it or not, they actually might have caused this second problem, whatever it is. Okay. In software, I refer to those, and maybe you use the same terminology, I refer to them as regression bugs, regression problems. Those are the mistakes, the problems, the bugs that are created while we are fixing other problems. All my life, since I started my career in software over 45 years ago now, I have been focusing so much on those regression problems. Why? Because in my experience, I found that those are killers. They really are bad. Why? Because if we don't take care of them, the customer gets very irritated. Nothing in my experience gets your customer irritated more than having things or features that work today, and then once they upgrade their software or once they get a new release, things are no longer working the way they worked before. Nothing irritates your customer more than that. Of course, some of you might say, well, we should have regression testing here in order to discover those. And you're probably a bit right, because if you have a good regression testing process, you should be able to find most of those, but not all of them. And that's why I am going to speak later on, later in this presentation. I'm going to talk about what it means to have a good regression testing, because certainly a good regression testing process that's based on impact analysis, as I'm going to talk about it, because if you remember, this was my last item in the agenda. Hopefully we'll get to it today before my presentation time is over. Impact analysis is very important to take care of those bugs that were created, the regression bugs. But we wanted to even prevent those bugs. Okay, so really regression bugs are critical, because if we don't get them, if we don't catch them during regression testing, they cause so many problems in the field. Because the problem that those regression problems, no one knows about them. You know that. I mean, when developers give you the next build or the next sprint, and they had fixed some problems, they have introduced some issues. No developer is going to say, here are the fixes that you need to test. However, I also created those other problems that you need to test them too. So it turns out that developers do not know anything about those newly generated or created bugs because they actually created them without knowing. And hopefully I can share with you why this happens, because of course I worked for so many years as a developer. I also worked with developers. I've seen the causes of those. Until today, when I see those regression problems, I'm very, very, very strict about them. I ask my development leads to find out when they were introduced and who introduced them. And that's okay to be able to know the specific developers who introduced those regression problems, because I have a number of developers working on one of the products that I am managing that are not so good. They have skills in introducing new regression testing. So that's why we assign those developers to do things that are not so dangerous, because, for example, of course, we know that if you make changes to a database table or the database structure, that's one of the main sources of those regression bugs. So if a developer is not very good at that, then he or she can really do bad things and cause a lot of damage by making change to the database table, which can cause a bunch of features are no longer working. So that's why we keep those developers away from the database. They don't touch the database design. They don't do anything with the database. Yes, surely they can write code to access the database. They can write code to update records in the database, but not to change the schema or the design of the database. All right, there's too much details here for some of you. But the bottom line is there are ways to prevent those regression problems. All right. So what's happening here? Well, your customers get, if you don't have a good regression testing, if you do not do a good job in preventing those regression problems, those problems will go out to the customer and they will look very bad. And although, of course, everyone out there in the literature has said things about how much it costs to fix those problems, I am bringing your attention and the management attention not only to the cost of fixing those problems, but to the indirect cost of the interruption in the business, the frustration that the customer will have when they see those features that are no longer working. Okay, so what we need to do, basically looking at this diagram, what we need to do is to reduce or minimize the flow of bug reports going from the test team and eventually from the customer back to the development team. So you heard it right. My goal is to reduce or minimize the flow of bug reports coming back here, because we already learned that the more bugs we find, the more bugs development people fix, the more regression problems they will create. Now, people out there in the literature talk about different ratios. I've seen people saying the ratio is 1 to 4 or 1 to 3, which means that in the average, every time a developer fixes one problem or fixes one bug, they create 3 other problems somewhere else. And as I said, those areas where the problems were created are not known. So I think in my own experience, 4 or 3 or 1 to 3 or 1 to 4 is too high of a ratio. So what I do now is I get developers to tell me their own ratio. So when I speak with developers, when I teach my courses to developers, and I have a number of courses I teach that includes unit testing and regression testing and things like that, and most importantly, integration testing, and I ask developers, I say, what do you think when you fix problems in your code and your design? Can you tell me that you do not create any problems anywhere else? I have not gotten one single developer who's willing to say, yes, I do not create problems anywhere else. Well, every once in a while, you get an arrogant developer who is willing to say that. But of course, we don't believe him or her. But most developers are willing to agree on a ratio in the average of, or an average ratio, I should say, of 1-to-1. And I'm not saying that means that every time the developer fixes a problem, they create a problem somewhere else or they break the software somewhere else. No, we're talking about average. Average means it's average between all developers, average between all bug report fixes, average between all types of software. Most people are willing to agree on 1-to-1. Most levels of management are willing to agree on 1-to-1. All right. But that by itself is very bad. 1-to-1 is very bad. You know what that means? Every time we write a bug report, we send it to the development team, we get the bug fix, and we get another problem that we don't know about. All right. And as I said, if we don't catch this during regression testing, it's going to go out to the customer. So over time, you can imagine the more testing we do and the more bug reports we write, the more defective the software becomes. I know it never occurred to you. You never imagined that. Please, if you have a different opinion of about what I'm saying or objection, or you don't agree to that, please share your thoughts with me on the questions tab. Okay, and of course, if you also agree, if you have experience, even if you have different experience, please share them with us, because that's how we learn from each other. Now, this is how I have come to where I am now, is by learning from many of you and many of the people I teach and many of the organizations I go to. So please share with me your opinion, your thoughts, your objections, whatever you want to share with us. And when I share them with audience, I will promise I will not mention your name. So that your developers do not get irritated at you. Yes, we need to reduce the number or the flow of bug reports from testing or from customers back to the development team. Some people joke about that, says, okay, maybe we shouldn't be doing any testing then, because you're saying the more testing we do and the more bug reports we write, the more problems we get. Well, not exactly. Not doing testing is not the solution, because when you do testing, you discover a lot of problems, and your hope is that the developer who's going to fix the bug is a good developer who is not going to create those bugs. But yes, if you look at at the statistics, it is like that. If I'm able to get developers to agree on 1-to-1 ratio, and if I have developers with me, by the way, here today, I want to hear your opinion. Honestly, if I have a developer with me today, please tell me if you disagree with 1-to-1 ratio. Tell me if, in fact, you can confirm it to all of us today that you never created a problem when you fixed a problem. When you fixed the bug report, you never broke the software anywhere else. And I know the word never is a strong one, but tell me, what is your average ratio? I would love to hear that from developers. I'll share them with you again without sharing your name. All right. So how do we do that? How do we reduce the flow of bug reports from going from testing or from customers back to development team. That's the trick. Anything you can do to do that is critical. All right, I'll move on because we still have a lot of things to talk about. I have not gotten anything, by the way, yet in the questions tab. Maybe I don't have developers here. I don't have the titles of those who joined us today in front of me, so I don't know how many developers we have. All right, I want to help you understand defect prevention. Let me start by making it very clear, very, very clear to you. Early detection is not prevention. It is detection. So if you do anything to find the problems, then you're not preventing them, as I said very clearly. If you found a defect, then anytime, whether early, and early meaning what? Even during requirement reviews. Because I say this because so many people focus on code reviews and design reviews. And I've heard many people saying code reviews and design reviews are a good way to prevent defects. Prevent defects from going where? Sure, from going to our customer. But the defects are already in the code. So if you do a code review or a design review, and you find defects in the code or in the design, even in the requirement, if you find the problem with the requirement, then the problem is there. Then you did not prevent it. Someone says, well, where else would I prevent it? A business analyst wrote a requirement, or a product owner wrote a user story. It's, by the way, it's very hard because user stories are very brief. It's very hard to find the problems in the user story. We may find out when we flush out the details of the user story, we'll find that there's so many details that are missing. But anyway, if you find defects anywhere, anytime, then you did not prevent those defects. So we are working on how to prevent those defects early. And of course, for management, if we prevent defects, and then we never have to pay for fixing them. Phil Crosby says the error that isn't made cannot be missed. You would not miss a defect that was not made. So I know it's kind of obvious, but that's what Phil Crosby said, one of the pioneers of software quality, in general, quality management. And in my experience over the years, the most cost-effective way to produce software that's high-quality software is by working very hard on defect prevention. You might have heard me saying in places on LinkedIn and other places that we have to work much harder on preventing defects. Someone saw this on LinkedIn and came back to me, said, Magdy, people will not like it when you say we have to work harder. I said, we've got to work harder. So, okay, what do you want me to say? Should I say we have to work smarter at preventing defects? Fine. Do whatever you want. We just have to prevent defects. Okay, let's move on and talk about very important concept. Many of you probably have the term quality assurance or QA either in your title or in the name of your department. You work for the QA team. You hear the QA team, the QA process, the QA analyst, QA. Funny enough that I hear QA tester sometime. You'll see in a little bit, unless you already know that the term does not make any sense. QA tester, QA team does not make much sense. I'll tell you why. Years ago, many years ago, probably was around the time I came to the United States in the early 1981. I was very privileged to attend a presentation by one of the pioneers of quality management, and that's Dr. Edward Deming. Some of you might know the name. Edward Deming at that time was a very popular man, and he had just come back from Japan after he left the United States years before, when no one here in the United States listened to his teachings and his advice. He went to Japan, he stayed there, and everyone knows that his teachings caused the industrial revolution in Japan. So he came back to the United States around that time, and I was privileged to attend his presentation. Even I had about 7 years of experience in software, but I didn't have much of experience in quality management and software quality and so on. But I was very taken by what Dr. Deming said, and this is what resonated in my thoughts and in my mind since I heard it. It was very, very effective. You know, when you hear someone speaking one time and he or she says something that really stays in your mind the rest of your life, and it affects you and your work the rest of your life. And I remember when he started talking, he said, "How are we doing?" And everyone said, "Good." And he said, "No, terrible. We are all doing terrible." And what he was describing, he said, we're going into a non-ending cycle. We inspect things, we find the problems in the products, and we go and fix those problems. And while we're fixing those problems, we create other problems, although in hardware, that's not likely to happen. But he said, we keep going into the same cycle. We find problems, we fix them, we get the new product, we get more problems, we fix them, and so on. And we know it never ends. And he was talking mainly about the process that's called quality control, and this was his way of introducing the concept of quality assurance. Okay, and basically, without wasting much of your time, I put on this slide the summary of what I learned that day. Of course, I changed this over the years. I reworded it. I put my experience into it, but that's mostly the difference between quality assurance and quality control. Quality control, if you are focusing on a product, keep that in mind. If you are looking at a product and all that you're trying to do is to find defects or problems in that product, and normally it happens at the end of a life cycle, at the end of when a product is already produced. Okay, if you are focusing on finding those problems, if that's all what you're doing, like what we're doing in testing, then that's quality control. So quality control is about inspecting or testing a product to find defects, and either fix those defects before they go to your customer, or just return the product back. If this was an electronic component or whatever that cannot be fixed, we threw them away, and that's expensive too. So if that's all what you're focusing on, that is quality control. That's why you are mistaken when you have been calling your testing activities quality assurance. Why? Because that has nothing to do with quality assurance. Quality assurance, as I understood it from Dr. Deming and the others, and as I experienced it myself, is something you do on an ongoing basis. And when you do it, you're not at all focusing on a product. You're really focusing on the process. So the way we do it is we go back to the process that produced a product, and we find out what is in that process that's causing the problems in the product, and we fix that. What do we fix? We fix the process. The hope is this: when this process that has been fixed is used to produce more products, those products do not have the problems. So really, quality assurance is about preventing defects by focusing on the process. That's all what it is. So in order to do a good quality assurance, we have to do good analysis to the defects we found already through quality control, and to try to find the causes or the root cause of those defects, and find where in the process those defects are being created, and we focus on those. My apology for kind of dwelling too much on this, because I'm sure some of you listening to me today probably know this discussion, but in my experience, I find so many people in software do not know the difference. Now I'm surprising you by telling you that you are not a QA person yet if all that you're doing is writing bug reports. If you are testing software and writing bug reports. But I know many of you would say, but that's what they hired me for. They hired me as a QA analyst, or even what they call QA engineer. But they told me to find problems and write bug reports. I understand. But today, what I'm asking you to do is, when you do your job, you do it with QA in mind. You do it with defect prevention in mind. So defect prevention truly belongs to quality assurance. It does not belong to quality control. Defect prevention is not about testing. The only thing in testing is that we could look at the defects we find in testing to analyze them, to find out where in the process we need to improve. But I'm going to give you this information already today, because of course you can imagine in over 40 years of experience, I have learned the sources of defects in software. I don't want you to go and analyze, although I always advise managers to go and look at the defect log and find out, or analyze to find out, what is the root cause of those problems. If we do not find the root cause of a problem, then we are not going to prevent the problem. So no defect prevention, no prevention of problems without finding the root cause. So we need to analyze problems to find the root cause. As I said again, I know most of you are test professionals sitting here and saying, well, yeah, but I don't get paid to analyze defects. I don't get paid to prevent defects. Well, I'll show you how you can prevent defects in your job as a tester. But for now, I always want to tell you, as a tester professional, you must become a QA professional at heart. You must become a defect preventer at heart. Okay, not just a defect finder, not a defect detector, a defect preventer. You want to always think about defect prevention. I want you, when you find a bug, I want you to think about it. What could have we done to prevent this defect? Okay, and please, I know so many testers who would stick with their idea about, I do what I'm hired for. I run tests, I write test cases, I know how to write good test cases, I know how to run test cases, I know how to do test automation, I know how to write bug reports. That's what I do. That's my job. Well, let me tell you something that I'm sure you're aware of. If that's your job, and if that's the only thing you do, let me tell you that your job is easily replaced by something else. You already know that we lost so many of our testing jobs to offshores. The first jobs that are being offshored are testing. And now we can see also development jobs are being offshored. We know that. You know that. All right. Thank God we still have a lot of jobs here in the United States. I know many companies, very large companies, that used to have hundreds and hundreds of test professionals and large test teams. They don't anymore. They don't, because those jobs are sent overseas. Okay, someone else is getting those jobs and getting paid much less. So your company is convinced that they can save money by sending those testing jobs offshore. When I talk to people of how to prevent defects, I get a lot of resistance from some testers, by the way, because I mean, the very simple-minded people will say, if I prevent defects, then I'm not going to write bug reports anymore. Sure, you will not. I already told you, my goal today is to reduce and minimize the flow of bug reports that the test team writes. Let me tell you this. One of the methods I'm going to teach you today, which is a scenario-based development and testing, I've been told by managers, specific manager in a specific company, that they were able to reduce the number of bug reports by more than 70%. I'm not just telling you things here that are textbook material. I'm telling you that things that have been used, have been tested, very well tested, have been used by organizations that produce results. I'm told face to face by the director of system integration in a large company that they were able, by using the scenario-based development and testing, they were able to reduce the number of bug reports by more than 70%. You know, by doing that, they did not only reduce the cost of fixing those problems, they reduced the frustration and the interruption in the business when those bug reports go out to the customer. Okay, so let's move on. For some reason, I do not get any answers or even any comments. Please share your thoughts with me if you have any. Okay. Now, I have for you here 3 areas, 3 sources of defects, 3 reasons why we have those defects that are most expensive to fix. Okay. First one is code that's written by developers that implements functionality that testers are not aware of. I know this comes as a surprise to some of you. I'm talking about the gap between what the design and the code is and what the test case is doing, and what the testers are testing. I know for some of you, you never thought there is a gap. Trust me, I learned it the hard way. I learned about this gap the hard way back in the mid-90s, okay, when I was involved in a project and I was brought in from outside. At the time, I was still teaching as a professor at the University of St. Thomas in Minneapolis. And I was teaching mainly in the Masters of Software Engineering. And I was teaching courses on software quality back in mid-90s. And I was brought into that project by some of the students that are attending the master's program. This master's program is, by the way, is amazing because it's not for people who just graduated from college who want to get a master's degree. This is for professionals who have experience in software who want to go to do a master's degree. So all my students in the classroom were project managers, test managers, QA managers. They were testers, they were developers. So anyway, brought to this project. Long story short, I was brought in. Funny enough, I always remember that. Funny enough that people brought me in for me to determine if they have done enough testing or not. Of course, this was a huge government project, and I said, how am I gonna even determine if enough testing has been done or not? So it took me a while. It took me 3-4 months to figure things out. And then at the end, I decided to use a code coverage tool because it is the most precise way to understand how much of the code has been tested. And the big shock came when I found out that the code coverage was 58%, which means 42% of the code that was written by developers have not even been tested. Of course, you can imagine the test teams did not believe that. The test teams did not believe that. So I spent a lot of time studying, and I learned about why the gap, and then I came to the concept of, okay, we need to do anything to close the gap. Okay, I'm just I don't need to tell you the rest of my experience with that project. I just wanted to tell you that this is how I learned it, that there is always a gap, whether we are willing to admit it or not. There is always a gap between developers and testers. I have another slide later on, I believe, about why we have this gap. But please believe me, okay? If you're here to spend an hour with me, believe me, there is a huge gap, and the gap is different. Of course, there are good news that the Agile approach have tried to minimize that gap, because the Agile approach calls for a lot of collaborations between developers and testers and the whole project team and so on. But again, the gap I am talking about really cannot be reduced or minimized by some of the things we do in Agile project. A lot of people put a lot of emphasis on the stand-up meetings that we do in the morning in Agile projects. Let me tell you that don't let those stand-up meetings fool you. They do not even address the gap, because the gap I'm talking about more explicitly is between what? Between what's in the design and what's in the code, and what is in the test suites, what's in the test design, what developers are being tested, what testers are being testing. And then let me tell you that depending on your process, that gap can be huge. If you want to know how huge it is, go ahead and use a code coverage tool to learn. All right. So that's one source of major problems. Why? Because if there is code there that has not been tested, it goes out the door, it goes to production without being tested. That's where the problem is. And now, of course, the customer find out about those problems, and they write the bug reports. And now those bug reports are very difficult to fix. Why? Because they have not been tested to start with. Okay, so developers have to go back, find out where the problem is, and they fix the problem, and they send it to you to retest. Again, they are about functionality, and I know many of you would say, how come there is functionality there that I don't know about? Well, maybe you should wait for my slide on the gap and why the gap is there. Okay, the second source is what? Scenarios that have not been thought of by anybody. Scenarios. And that's why scenario-based development and testing is my main weapon, to attack this source of problems. All right, scenarios. Scenarios that are encountered in the field that no one ever thought about. I want you to think for a minute here. I want to look at any bug report that comes from a customer and think about, why did the customer find this problem and why didn't we find it? How come our test team did not find it? Okay, because obviously if the customer found it, then we did not find it. Because if we found it, we would have written a bug report, then developers would have fixed it, right? Common sense. So why did our customer find it and we did not? You're gonna find that those fall mainly within the first two categories. It's either code that was written that implements functionality that testers did not know about, that's why they never tested it, or even a scenario that no one thought about. No one thought that a user can do this. Okay, and the third source, of course, as I said earlier, is bad fixes, which are regression defects. All right, let's move on. So here is why the gap is, very briefly. Again, one more time, whether this happens or not, there is so much we can do here to minimize the gap, by the way. Okay, I'm focusing on that gap. Okay, why the gap is there first is because requirements are always incomplete. So a lot of details about the requirement and about the user story come during development. Many assumptions are being made. Let me tell you this. We all make assumptions. Developers make assumptions. Testers make assumptions. We all make assumptions even in our daily life. Okay, without validating those assumptions. Am I saying that we should not be making assumptions? Absolutely not. You can make assumptions. But for every one of us, testers, developers, anyone, including myself, please know, any assumptions you make remains invalid until you validate it. As a result, any decision you make and any position you take based on an assumption you made without validating it could be a very wrong position. And think about your daily life. And I can give you tons of examples of decisions that people make, positions that people take based on assumptions they made, and their assumption was wrong. And as a result, the decision they made is wrong. Okay, trust me. I learned this the very hard ways. You make assumption, keep in mind it's invalid until you validate it, and don't ever make a decision or take a position based on an assumption that you do not know if it is valid or not. Go back to every decision you make. Go back. So why am I telling you this? Because what we do in our daily life, we have to learn from in our test software experience. Okay. So developers make assumptions all the time without making sure they are correct. And they go and write code and do design based on those assumptions. And they don't go and validate their assumptions. Now, those good developers that are willing to validate their assumptions, they go and validate their assumptions with who? With who? With the product owner, with the business analyst. They assume certain things. And as I said, some developers will assume certain things in the requirement, and they will write the code and they will do the design based on that without telling you. And other developers, other good developers, will assume things, will go back to the business analyst or the product owner who wrote the requirement and say, I am assuming this and this and that, right? So the business analyst says, yes. Okay, good, great. Go write the code, change the code, write the design, make a change to the design. Do they ever come to you as a tester professional says, oh, by the way, I asked the business analyst, I asked the product owner about this, and here's what he said, and as a result, I am changing my code to do this? No. I'm not saying that they are bad developers. They're just not in their mission. It's not in their purpose. They're not saying, they don't need to come and share with you any, because they don't know how important it is, okay? As a result of this gap, my experience is that we, as test professionals, are not able to test more than 50 to 60%. All right, so how do we close the gap? Here are 5 ways to close the gaps. Collaborative, requirement, and user story reviews. Oh, you're going to see this now and say, oh, Magdy, I thought you said reviews are not defective prevention. I am not. Remember, I'm focusing on closing the gap. So my purpose here to do collaborative requirement reviews. And by the way, collaborative ongoing online does not mean there is meetings. There are no meetings here. Even down here, number 4, I say code and design review meetings. Okay, what are those? Those are ongoing. But how did I say in the beginning that don't focus on code and design reviews as a way to defective prevention, but now I'm listing it as one of my ways to close a gap, because that's the purpose. Now ask yourself, why do we do code reviews? Everyone tells you that we do the code reviews and the design reviews and the requirement reviews to do what? To find problems. I say that is not the point. Sure, you can find problems, but that's not my goal. Those review processes, whether they are code or design or anything else, they're mainly to close the gap between what developers are thinking and what testers are thinking, what developers know and not what testers know. Once we are all on the same page, then we can make sure that testers are actually testing everything in the code. Scenario-based development and testing. And I don't have time to share it with you here because I have a whole presentation that I made probably, 2-3 weeks ago. It was actually before holidays. Please go to our website, testinginstitute.com. There is a recorded presentation on scenario-based development and testing, and you'll understand the whole process. But that's simply that process is the one that I was telling you that people are able to reduce the number of bug reports by more than 70%. Okay, and it's a very simple process. When you look at it, you're going to find out it's a common sense. This is how we're supposed to be building software. All right. What is daily or weekly update meetings? Many of you kind of put a lot of weight on stand-up meetings in the Agile projects. I found that those stand-up meetings, although they are useful in kind of updating everybody with what's going on, what went on yesterday, what are we going to be doing today, but they're not very good at closing the gap. I'm suggesting to implement those daily meetings mainly for the testers and developers to share with each other any differences. Simply, a developer needs to ask herself or himself, have I done anything today or yesterday or the week before that affects the way the tester should do her work? And the tester would do the same. Have I done anything that affects the way a developer would do his or her work? And so that's mainly an update meeting. I don't know what else to call it. It's a daily or weekly update meeting about the differences. The reason here is to close the gap. I have so much details about this stuff. This is an hour presentation, 1 hour presentation, guys. I cannot share all the details with you. But here is scenario-based development and testing, a glimpse at it, but you sure can get all the details from the recorded webinar. Very quickly, you look here. You look here, you can start from requirement, you can start from user story, you can start from use cases if you have those, whatever starting point you have, and you have those collaborative analysis and reviews for any one of those things. At the same time, we collaboratively develop and validate scenarios. See, the process is all concurrent here. But most importantly, at the end, those scenarios that have been developed and validated goes to the test team to write their test design, and they go to the development team to write their code and their design. Why am I doing that? Because I want these two teams to work from the same page. And the page I'm talking about is the scenarios that have been validated. Scenarios are very, very detailed. Now, if you are working on an Agile project and you're saying, oh, is this the same as the acceptance criteria that we write for user stories? I have another presentation that's also recorded. I think the title is Acceptance Criteria versus Scenarios. It's recorded on the Testing Institute website. Please go ahead and listen to that. You can see the difference between scenarios and acceptance criteria. And I also touch on acceptance criteria in the presentation about scenarios. All right. This is the collaborative reviews. It's asynchronous, meaning that we don't do it at the same time. We use a tool, whatever tool you like. I use a tool called Romana from our sister company, Romana Software. You can use Jira. You can use whatever tool you have. But the point is, we all review, not at the same time. We put our comments and our reviews in the repository. The last thing I want to talk about quick here is impact analysis and how we use impact analysis in regression testing. Basically go back to a very simple analogy here. I know my time is over. I'm going to use another 1 or 2 minutes here to finish. Everyone who fixes a problem needs to be accountable for the work they did. This is like going back to the shop where you took your car to, and you're simply telling the mechanic who fixed your car, you say, please, when you fix my car, I want you to make sure that you have not broken anything else. You have not caused a problem somewhere else, because I do not want to take the car and drive it and a week later I find a problem. Now, that mechanic need to learn how to do impact analysis. So with that same thing, I'm saying developers, our wonderful developers who fix the problems, need to learn about impact analysis. They have to know how to analyze the fixes they made to the software to make sure it does not have impact on other areas. All right. You as a tester have a role there. You can actually request what I call the impact analysis report or impact analysis notes from developers. If you look at the Romana ALM tool that I'm using, when there's an issue that's being fixed by developers, there is an important field there, and make that please required from your developers that they provide the impact of the changes they made. Anytime we have, because impacts happen in two places. One, when a developer fixes a problem. Two, when a developer makes change to any code or any design. Anytime developers make that, they have to note the impact of the changes they made. If they tell us the impact, we can use this impact analysis in our regression testing. So our regression testing should be smart. I know the way we do regression testing. It's a very typical. We have a regression test suite that we repeat it every time we have a build that's going out. Please make sure that when you put together your regression test suite, it uses the impact analysis information given by your developer. I have a 3-day course where I cover all this stuff in details, impact analysis, regression testing, scenario-based development and testing. I teach you this course through the International Institute for Software Testing. All these presentations I make are kind of taken from that course. But of course, I don't have enough time to cover everything in details. My conclusion here, please, always strive to prevent defects, okay? Remember that also always rework will always cost more than doing it right the first time. So defect prevention is about doing it right the first time. People speak about how to do it right the first time, but they provide no way of doing that. The only way I know to do it right the first time is with the things I mentioned in the previous slide right here. Not the previous slide, but the ways to close the gap. Okay, this is how you do it right the first time. All right. Please be convinced that anytime developers rework or fix a problem, they will always introduce new problems, and we call those bad fixes. And as I always say, if you find a defect that you did not prevent it. Preventing defects is not about finding defects. My apology for going about 5 minutes beyond my time here. Thank you so much for joining me in this webinar. As I mentioned, this webinar is being recorded, will be made available. I don't see questions in the questions tab. Thank you again, and hopefully we'll meet you. We have 4 more webinars coming in. Please go to the Testing Institute website to see the schedule of webinars. Thank you.